Very tricky question here. Let's begin by drawing a picture of a 30, 60, 90 right triangle. And they will also give you the information that I'm going to draw here in the reference area. So while you don't have to have the 30, 60, 90 triangle memorized, it's probably a good idea that you do so. So the side across from the 30 will be x, the side across from 60 will be x rat 3, and the side across from the 90-degree angle, aka the hypotenuse, will be 2x. So we know the perimeter of our right triangle is 27 plus 27 radical 3. So one thing you might do right out of the gate is say, well, look, there's my x radical 3. Right? There's the radical 3. It must come from this side. So that means what? Well, I know that x would be 27. Okay. So this is 27 radical 3. And so this would be 27. And then this would be 54. So at this point, we're kind of confused because it says the shortest side is a square root of b. But in our triangle here, the shortest side is 27. What's going on here? Something's off. And in addition, if I sum these sides to find the perimeter of this triangle I've created, I do not get 27 plus 27 radical 3. I get 81 plus 27 radical 3. So something is very strange here. You might also, in a similar vein, say, well, look, the perimeter of this triangle with the x's in it, it's going to be x plus 2x, which is 3x, and then plus this x radical 3. So that is the perimeter of any general 30, 60, 90 triangle. And you might then set this equal to 27 plus 27 radical 3. And then in a similar way, you might then say, well, okay, that equals that, and that means this equals this. But then we run into this problem. It's not working out. Here's the thing. This is only really going to come up on harder questions. A question like this would be towards the end of a hard math module. Most of the time, when you make that quick assumption that, oh, the radical 3 goes with the radical 3 side, you'd be fine, almost always. But we can't assume it. We can't assume it, especially on these harder questions. Kind of like we saw on the previous video in this series where we looked at trig functions. At the end of the day, 30, 60, 90 triangles, it's just trig without the trig, basically, because it's all about the ratios of the sides. So when we're given this picture for the 30, 60, 90 triangle, we have to remember that they're basically telling us ratios of sides. It's not necessarily the case that the side across from the 60 will have a square root of 3 visible. It may not. Often will, but it may not. At the end of the day, what matters is that the ratio between these three sides is preserved. So when you run into these problems, you can try the obvious approach is to assume that, okay, this must be the x rat 3 side, but then check your work. And if it doesn't work, how do we adjust? Here's how you can adjust with our setup here with our perimeters. Instead of assuming that, well, this term must match this term, let's make the assumption that this term actually matches this term, and that ultimately this x radical 3 is this 27, actually. It's not the 27 radical 3, which would mean the 3x would correspond to 27 radical 3. And now let's see, when I solve for x using these two equalities, do I get the same x? So for example, x radical 3 is equal to 27. Well, let's divide both sides by radical 3. Let's rationalize. We'll multiply the top and the bottom by radical 3 over radical 3. So we're going to get 27 radical 3 over, and then radical 3 times radical 3 is 3. This 3 will cancel a 3 in the numerator, and we're left with x is 9 radical 3. So that's what we got from solving when x radical 3 equaled 27. But let's also solve, what if 3x is equal to 27 radical 3? What would be the value of x? Well, if I divide both sides by 3, notice we get the exact same answer, which is good. You want to see that consistency. So let's fill in our info here. We have x radical 3 is 27. X is going to be 9 radical 3 at this point. And then our 2x will be 2 times 9 radical 3. So it's 18 radical 3. And here's our final check. What is the perimeter of this triangle? Well, it's 27 plus 9 radical 3 plus 18 radical 3. And that's 27 plus 27 radical 3. So we're good. This matches the situation. And again, the x radical 3 side, the side across from the 30, does not end up having a radical 3 apparently visible, right? But when we look at the ratio of these two, the ratio is correct, right? If I take 9 radical 3 and I multiply it by radical 3 to get this side, again, we get 27. So all is well. This is totally fine. Now we have to answer the question. The shortest side is a radical b. So this is going to be the shortest side, right? It's our x side. So it's 9 radical 3 And A, therefore, is 9 and B is 3. So what is A plus B? So A plus B will just be 9 plus 3, and that is 12. So, and that is our answer. So on these harder 30, 60, 90, and sometimes you'll see this in 45, 45, 90 questions, first try, assume that the obvious is obvious, right? That the thing with the radical 3 is the side with the radical 3, or the part with the radical 2 in the case of a 45, 45, 90 is the side with the radical 2 in the diagram. Make that assumption, but double check, right? Make sure everything is consistent. If there's an inconsistency, you probably need to flip it around. Like in this case, assume, actually, no, the side with the radical 3 is actually the x, and so x radical 3 will be, therefore, the side without the radical 3. It's strange, but again, it's this distinction between ratios of sides and the actual lengths of sides. Very similar to what we saw in the previous question involving trig. So this one is going to be 12.